Babe.
All right, we're good.
All right. Anybody have any questions, or do we just want to go take the quiz?
I have some questions, but I'm pretty sure they'll get answered in the quiz, so we can just go into the quiz.
Okay.
I feel like a million tabs open. I'm gonna close some of these.
I'm in the quiz whenever you guys get there.
I'm pulling it up.
I also am in the quiz. I imagine I'll probably need the normal probability applet.
We will.
Oh.
All right. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and to the left of z equals negative 1.358. Okay.
I got 0.175.
I got the same.
Any objections?
I'm sorry, what did you say?
For question number 3, I got 0.175.
Yep.
I'm almost done. .175.
Boom.
Love it when we all agree like that.
I know. Makes these things go a lot quicker.
Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population?
Oh, no. Individual observations.
So I have B, or the distribution of the sample means.
And why is that? Just a rule of thumb?
Because, yeah, essentially, when you talk about the distribution of the sample means, the standard deviation of the sample means is divided by the square root of the number of observations, so 9 in this case. So it will always be smaller than the individual observations.
Okay.
Because you divide the standard deviation by a number.
Yeah.
Unless that number is less than 0.
Okay, which of the following results implies that the spread in sample means decreases and the sample size increases?
Oh. It's either the central limit theorem or the law of large numbers, and I get those things confused.
I think it's the law of large numbers.
I also think it's the law of large numbers.
Somebody want to throw out a quick definition of that real quick?
Yeah, let me pull one up.
The central limit theorem just says if you have enough data points, enough of your sample size is big enough, then the distribution of means is normal.
Yeah, the law of large
it means
numbers,
that the mean approaches the mean of the whole population.
The law of large numbers says that as the sample size increases, the standard deviation of the sample mean will get smaller. Is that their question?
Yes.
This spread decreases, sample size decreases. Law of large numbers states that sample size increases, deviation gets smaller.
Yeah, that's what this is saying.
Yeah, it's the opposite, but yeah.
It says decreases and increases.
Okay. Scores on the quantitative portion of the GRE are approximately normally distributed, with a mean of mu equals 150.8 and a standard deviation of 8.8. Question 6. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? That is going to be 160 minus 150.8 divided by 8.8.
142.86.
I got 1.0445.
So it's 160 minus the mean 150.8, right?
Yep.
Yeah.
By standard deviation
Yep.
8.8. And that's the answer.
Yeah.
What am I doing wrong?
What'd you get that time?
I get 142 point something.
So
160
you've got
minus.
9.2 divided by 8.8, right?
Wait, what?
Okay, wait,
What's 160 minus 150.8?
Like 10, right?
Right.
Yeah,
So
close-
that
close to
divided
10,
by
yeah.
8.8.
Okay.
divided by 8.8 is 1.045.
That's what I got.
Yeah. Wait, still didn't get that. Hold on. 160.
Spencer, you're
minus-
making me doubt myself.
No, I got 1.045.
There we
That's-
go. There we go.
Spencer's the one making us doubt.
Sorry, got it. Yeah. Sorry. I'm using like the simplified calculator and it's rounding for me. It's not showing me. So yeah, we're good.
Cool. Number 7. What is the probability that a randomly selected student will score above 160? So you take that z-score and you throw it into
The normal probability applet.
and you just look at everything to the right of it, right?
Yep, I believe that's correct. So I got 0.148.
Me as well.
Sorry guys.
What did you guys
What
get?
did? Go ahead.
I got 0.148.
I got the same.
What
You
did we get
take
for the
the-
last one?
1.045 is question 6. Question 7 is 0.148.
0.148, right?
Yeah.
Right.
Okay. 'Cause when you guys are saying it on my computer, it sounds like I'm saying 0.48. I'm like, oh gosh, that is not what I got.
Yeah. Question 8. A sample of 5 students was selected. Their scores were these. What is the z-score corresponding to the sample mean of these students' scores?
So we take the mean of these things and then subtract the mean from our mean. Is that right?
No, you have to like divide by the square root of the sample size and all that to find blah, 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 blah. You know what I'm talking about? Yeah.
I do know what you're talking about. Is that all we have to do here is divide by the square root of 5?
No. So you have to find the mean of all those numbers.
Right, and then subtract the mean from that and then divide by the standard deviation and then divide again by the square root of 5. Is that all right?
It's divided by the standard deviation divided by the square root of 5.
Is that different than what I said?
Yes, it is.
160, I'm pretty sure.
I got 160.
Yeah, that's the mean. 160 is the mean.
Yeah,
Okay.
Mhm.
minus
So-
150.8. Or do we not do minus 150.8?
To take the mean.
Yeah, you do. Because that's the
50.8
yep.
divided by 8.8 is the same as the first number that we got.
No, you have to take 8.8 and divide it by the square root of 5
Oh gosh.
because we're talking about sample mean here and not just the population.
Okay, can somebody tell me what that number is?
Got 2.338.
Hold on a second.
So 3.935.
What's the
Okay.
standard deviation? 8.8.
Yeah.
Yeah,
What'd you get? I got 2.338.
I got the same.
Bless you.
So one more time, walk me through that. You take standard deviation divided by a square root of 5, right?
Yeah, so the standard deviation divided by the square root of 5 gives you the standard deviation of the mean, of like the sample mean stuff. And then you just do a normal z-score formula with that number instead.
Okay.
So you take the mean minus, or you take the number minus the mean.
And the number we're using in
Divided.
this instance is just any of the other ones besides 160?
It's the average of those 5.
Oh, okay.
which turns out to be
Post the
160.
formula in the comments.
So,
So what did you guys get? I got 3.935.
I got 2.338.
I also got 2.338.
So I took the homework quiz thing for this section, and I got it. I got a lot of these things wrong, and I think, Mackenzie, what you're doing is maybe like, so if we go like 160 minus 150.8 divided by 8.8 divided by the square root of 5, what is that? 0.467? That wasn't the answer to either. That's how I was getting everything wrong before, though. Right?
Oh, dang it.
Mom and Dad set certain, like, some rules for while they're gone, and
Okay.
like,
He doesn't care about that.
just, yeah.
He had a.
I posted a formula in the comments that looks really scary, but it's the same thing that Taylor said.
Yours just has the it's the symbolic representation of my words.
Right. So it's the same thing. It's the average that we get minus the mean divided by the standard deviation, which is divided by the square root of n. So you have to do those things separately, or else you'll get the wrong answer.
I should have probably put parentheses around my first thing, but I didn't do that. So.
Okay, so 2.338.
That's
Yep.
right.
Okay. Okay, number 9. What is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem?
It's not. First he called and I'm like, it's not up for another.
So,
So we post that score in the normal probability applet, and it's what's greater than it, right?
yep, you just take that number we just got and find out what's greater than it in the app.
She's not even being angry or short or.
I got 0.0097.
So rounded would be 0.010.
I mean, I guess I don't really like rounding things to have. Like
It says
Oh,
discuss-
It wants four, calm down.
It didn't even phase me though.
All right, everyone get 0.0097.
no.
What you got, Spencer?
Well, the z-score, it's 2.238.
2.338.
2.338. Okay. And then what do you guys get? Zero? Is it 0 point or? No, I'm still not getting it. I'm getting 0.0126.
So did you put in the normal probability applet? You have the z-score on the right, 2.338. The area selected on the right of that.
There's no marker. The marker's over there somewhere.
I'm getting Oh, just the right side.
Just
the right side.
You just only want what's greater.
So yeah, 0.0097. Is that
There you go. Yep.
See, then I don't know how people like decide a name beforehand and then stick with it. Like when they're kids, because to me it's like
Get names that are like.
what they look like.
Are
what they
you
feel.
thinking of
I know, you're just trying to get this.
relatives?
So what are we rounding that to?
Yeah.
0.01.
Yes.
No, just it wants all 4 decimal.
Oh, it does. Okay.
Or is that
Oh
just?
yeah, it does.
That's a.
Okay.
That's a.
Question 10.
Not an absolute, but like.
Suppose the mean of GPA students is 3.5 and the standard deviation is 0.7. The distribution is left skewed. A random sample of 81 students was drawn. What is the shape of the sampling distribution of the random variable x bar, which represents the sample mean of 81 students?
I think that that's approximately normal. Isn't 81 enough people, enough students that it's.
Yeah, anything higher than 30, regardless of what the parent distribution is, it will always be normal. So because 81 is bigger than 30, the average will be approximately normal.
We all agree with that?
Yeah.
I have it on.
All right. What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population?
When I was like.
This is the same as the mean of the parent population.
Yeah, which is 3.5.
Yeah.
Think
We had the 10.
That's what the central limit theorem says, is if you have enough
So,
of a sample size, then the means are the same.
myself.
Then the standard deviation is just 0.7, right?
No, it's 0.7 divided by the square root of the number of things we have.
I always forget about the square root.
So
It'll be interesting to see. Well, what's
what if
funny,
it's the same sample size?
that was a big pet
What?
peeve of mine. And it still is a pet
In
peeve of
question
mine.
12, it says, what is the standard deviation of the distribution of the sample means for all possible samples of size
Now
81?
I
When if you go to read the original thing,
haven't run my
it's
very
like
often.
our population size is 81, and
But the other day.
No,
Zadig was
that's
really
all
hot.
BYUI students. The sample size is 81. And so the question's asking, if you took any 81 students,
okay.
what's the standard deviation going to be?
So someone walk me through that. It's gonna be 0.7 divided by the square root of 81.
Which is 9, right? Hopefully.
Yeah, 9.
Yeah. And that's because it's dealing with the means.
So I went up there and I.
So you have to find out what the standard deviation of the means is, and that's why we divide by the square root of n.
Okay.
So 0.077, 0.078.
Mm-hmm.
Yep.
That's what I got.
And then that way you can do that.
So if you get the family tree half, and then.
Yeah.
Everyone good?
What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3?
Oh, is the answer just 9
Like both sides.
for question
No, the
11?
square root of 81 is 9, so you want to divide the standard deviation by 9. Are you talking for 12?
For 11.
Even though those are old.
Oh, for 11?
Those will fit in today's world with all the weird.
11, the answer is 3.5.
Victorian era.
The mean is the same as the population, parent population mean.
Gotcha. I was just behind. Okay, question 12.
So question 12 is the one that we were talking about how you 81, which is 9.
Yeah, we have to divide.
Yeah, so you do 0.7 divided by the square root of 81, which is 9, so it should be 0.078.
Yep.
Yep.
Wait, hold up. Super confused. Go back over that one more time.
So to find the standard deviation of the distribution of sample means,
Mm-hmm.
it's talking about, okay, so it says all possible sample sizes that could be drawn. So what you do is you take the standard deviation that's given up at the top,
Yes.
and then you divide that by the square root of the random sample, which was 81.
Got that.
The square root of 81 is 9, so you just do 0.7.
0.7 divided by 9.
Yeah,
Mhm.
which is
Yes.
Gotcha.
0.78.
Okay.
Newton John.
All right.
So for the next one, we just use, so 0.078 is the standard deviation, and then you just use that to find the z-score in the next one, just like you normally would.
Oh, sweet.
So you take the 3.3 and subtract 3.5 and divide it by 0.078.
Negative 2.564.
Yep.
That's the z-score, but it wants the probability of everything less than that.
Oh, so we need to put that in the applet.
Yeah. Negative 2.564. And then everything to the left, it's going to be pretty small. How many digits does it want?
0.0052.
Yeah,
I got
So I got-
0.0052.
So just 0.005, right? Because it only wants 3.
Oh, yep, you're right.
Students be greater than 3.3.
yeah.
And
So
then
it's
what is it greater than 3.3?
Everything
yeah.
is
So it's just
right.
everything else. Yeah. It's
Yeah, so
0.994.
Yeah, 0.995. Those two numbers should add up to 1, which they do. So,
0.095?
0.995.
Yeah. But every time we've gone to think of that,
This is the mean weight of passengers in commercial boats.
Ooh. Hey, can you answer this?
You said Tawanda?
Okay, so 0.995?
yeah.
Correct.
Okay.
So the United States Coast Guard assumes the mean weight of passengers in the commercial boats is 185 pounds.
Which
The
is
previous
nice.
value was lower, but was raised after a tragic boating accident. The standard deviation of passenger weight is 6.7 pounds. The weight of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme
You're
than
welcome.
was observed in this sample.
Thank you.
Okay. She just had toast.
Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme than observed in this sample.
All right, I've got an answer, but I don't know if it's right. So once you guys get there, let me know.
Okay, so do we use 48? Is that like the sample size for?
I believe
Yeah.
so.
I think so.
Okay. So square root of 48 and the standard div 26.7, 6.928. Okay, so that's the z-score. No.
What'd you get for the z-score? I got 1.920.
I got negative 0.1920, but yeah, it's the same.
Maybe I'm on.
Just a sec.
0.192 or 1.92?
Are they just slowing two fractions down?
Mine's a negative 1.92.
Okay, yeah. I mean, I got negative 2. I just put it in the positive.
What'd you get?
A negative
1.92.
1.920.
I got 1.95.
Basically, you're in the early stages of life.
How did you do
Yeah,
that?
that's just a rounding error probably.
Probably.
So you got negative 1 point something,
1.920.
and then it wants to know
Yeah, that's what Dr. Lee was saying.
everything that is.
That is not in the middle of the normal probability applet. Is that correct?
Says that I'll have the weight that is as extreme, so is as low, or more extreme.
So either
So that's
above-
only the low side.
Well, and then in parentheses it says either above or below the mean.
So yeah, just don't.
Yeah,
have the
that's
middle
just
area.
that thing in parentheses is just telling you that it's either going to be above or below the mean, but you only want one of them.
Oh.
Because the average is below the mean, then we have a negative z-score, and it wants to know what are the random sample of passengers that are as extreme as that or more extreme, which means are less than that, right?
Gotcha.
To get more extreme than that number, you'd have to go farther left.
Yeah.
So you just want the left side.
0.0274.
So I got 0.0274 as well.
All right, forget this.
0.027.
I am just going to submit this thing and see if we failed.
And see if we failed.
We got the last one wrong.
Which one?
The last one.
So I'm going to try with both sides, and I'm going to see if that 0.055.
If it does, then I'll be deeply sorrowful. I'm sorry.
That's the only one we got wrong?
Yeah.
And it was usually it's shorter than this.
And it's right.
Yeah, I forget you guys. Ain't nobody.
0.055.
0.055.
Alright,
You know what? I'm gonna take my 16 out of 17 and be happy with it.
Well, you could get a 17 out of 17.
I could, but that would require me to like write all these answers down and then like.
Yeah,
refer to-
it's type everything back in, and it's not worth it.
Here, I got a calculator pulled up. Let me figure out what that is for you real quick. It's that's a 94.
Yeah, I'm happy with that. That's an A.
guys, I can't hear you.
Mackenzie.
There was
All right, we good?
Cool job, team.
Good game.
All right. Thanks, everybody. I'm going to
Adios.
stop this broadcast. See you later.